We're going to solve some quadratic inequalities in this video. This is the worksheet from class that you have. The back is your homework. Step one when you solve a quadratic inequality is to pretend this was basically set equal to 0 and find out where it equal to 0. Find the zeros. Because we can't figure out where it's greater than 0 if we don't know where it first equals 0. So I figured out the zeros here. Now, you could have figured out the zeros by factoring, or you could have figured them out by the quadratic formula. No matter what, you can use the quadratic formula to find the zeros. So you never should say, I can't find the zeros, because you can always use the quadratic formula. So let's go ahead and put these zeros on the number line. Now, remember that the zeros are the x-intercepts on the graph. So if I had put in a y-axis here, those would be the x-intercepts from my graph. And we know the graph's a parabola. So we kind of want to sketch what the graph might look like. Now, we know the graph has to go through these points. So we need to know the parabola either has to come down like this and make a U, or go the other way and make an upside down U. Well, what determines that? Let's look at the leading coefficient. It's negative. So we know it's going to be an upside down parabola. It opens down. So the parabola has to look like something like this. So now we want to look at the graph and see, where is this graph positive above the x-axis, above the number line, and where is it negative below the x-axis, below the number line? So we can see right here, below negative 16, it's below the number line. So it's negative for numbers that are less than 16. Now between 16 and 8, we can see negative 16 and 8. We can see that it's positive in the middle. And then after 8, we can see it's negative. So this is our sign chart. We know it goes from negative to 0 to positive to 0 to negative. Now let's look at what the question's asking us. This is the last step. We have to look right here. Greater than 0. That's asking, where is this positive? And you can see that it's positive between negative 16 and 8. That is where the graph's above the x-axis. That is where all the y values here are positive, and that is where, if I plugged in these x values, this whole expression would come out greater than 0. So the answer here in interval notation would be negative 16, but not including it. That's why in parentheses to 8, not including it, because it can't equal 0. That's why we don't include those, because it actually equals 0 at those two numbers. So I'm going to go a little quicker here. This was just a little longer explanation. I'm not going to draw the graph every time in terms of putting this y-axis down. I'm still going to sketch it, but I'm not going to waste my time doing that. It wouldn't be very efficient. So let's come over here. So we have the zeros already. Let's put those on the number line. So negative 1 is actually smaller, so that'll come first. Negative 4/5. Now, which way is this parabola opening? Positive 5, so it's got to go and open up. So that means the graph has to hit these, so it's got to look like this. I don't even need to put these arrows, but I will. If I was graphing it in 2D, I would really need the arrows to express that it goes on forever, but I'm just using it to help me here. So it goes from, on this one, positive to negative to positive. And this one's asking, where is it greater than or equal to 0? And we can see that's on the outsides here. So in interval notation, that's going to be from negative infinity to negative 1, including negative 1 this time because it's or equal to, union negative 4/5, which if you wanted to, you could change as a decimal. It's negative 0.8 to infinity. Over here, let's take a look at number 3. Now, there's only imaginary zeros on this one because we have the I. So there's no real zeros. Remember, this is the x-axis, so we're only going to plot real zeros on here. There's no real zeros here, so we know that the whole graph is either above the x-axis or below the x-axis. And let's look at that leading coefficient again. It's a negative, so it's got to go down. Well, it can't be on top, because if it was on top, it would go through the x-axis, so it's got to go like this. So we can see on this one, it's negative everywhere, and they're asking us on this one, can you see it? Where is it greater than or equal to 0? Well, it's greater than or equal to 0 nowhere, so this one would be no solution. Now, number 4, the zeros here are irrational. So let's try to get a decimal approximation. So we want to split this up. 3 plus the square root of 185 over 8. And that's about 2.0 something, let's say 2.07. And 3 minus the square root of 185 over 8, which is about negative 1.32. So those are the zeros. Let's put those in the number line. Negative 1.32 is right here. And 2.07 is right here. Now let's take a look at the leading coefficient. It's positive. So it's going to open up, so it's going to look like this. And again, it's going to be plus, minus, plus. Let's take a look at the question. Where is it less than or equal to 0? We can see that happens in the middle here. So including the zeros this time, because it's or equal to, negative 1.32 to 2.07. All right, let's take a look at these bottom two questions here. Now this one here, look, we have plus or minus 0. Well, that's the same thing. It doesn't matter. This is a double root here. So that means that a couple things. Well, first, it means that there's only really one unique answer because this is all zeros. So it's only this. There's only really one solution. It's called a double root because it's the same answer twice. Now that also means that the vertex is on the x-axis here when we go to graph it, and there's only one x-intercept. So let's simplify this. Let's see, the zeros cancel out. So negative 2/5, which is about, in fact, it's not about, but exactly, negative 0.4. So let's put that there. So let's see again, the leading coefficient is positive, so it opens up. So that means it's got to come down here. The vertex is on the axes, and the graph looks like this. So we just have plus 0 plus. Let's see, where is it less than 0? Where is this less than 0? Well, it's positive here, and it's 0 here. Where is it less than 0? Nowhere, so it's no solution. Let's come over here to number 6. Again, we have irrational answers, so we want to approximate. Negative 1 plus the square root of 13 over 2 is probably about 1.3. And negative 1 minus the square root of 13 over 2 is probably about negative 4.6. Hey, I don't have a number line over here. Oh, I'll draw my own this time. Oh, that is really bad. I gotta try that again. Number line, nice and straight. Come on, here we go. Yeah. All right, that'll have to do. It's been a long video. Negative 4.6 to 1.3. Now on this one, again, positive leading coefficient, so it's opening up. It looks like this. So it goes from plus to minus to plus. Where is it greater than 0? On the outsides. So this is going to be negative 4.6. Let me fix that. It's not negative 4. Woo. It's going to go from negative infinity to negative 4.6 union 1.3 to infinity. So there's a few of the problems done on the worksheet from class. I'm going to finish up the worksheet here. On number 7, we can see that it has two imaginary zeros. We only put real zeros on the number line, and only real zeros are x-intercepts. So we think about this graph, it's either entirely above the x-axis or it's entirely below the x-axis. So that means this expression is either entirely positive for every value of x or entirely negative for every value of x. So we'll check the leading coefficient with this positive, so it's got to open up. That means the entire graph has to be above the x-axis, so it's always positive. Now this question asks us, where is it greater than 0? Well, it's greater than 0 everywhere, so that means it's all real numbers. You could say that it's negative infinity to infinity, or you could say the answer is all real numbers. And number 8, again, this one's going to be a double root because the discriminant is 0, so it's plus or minus 0. This is all 0, so there's only one unique solution, a double root of negative 3 over 2. So that means that the vertex is on the x-axis, so negative 3 over 2, which is about negative 1.5. Check the leading coefficient. It's negative, so this parabola is going to be opening down. So it comes like this. It hits the vertex, and it comes back down. We can see on both sides it's negative, and at negative 3 over 2, it's 0. This is asking us, where is it greater than or equal to 0? Well, it's never greater than 0, but at negative 3 over 2, it actually equals 0. So negative 3 over 2 is the only answer here. So we can just say it's a negative 3 over 2. Or we could say that x equals negative 3 over 2.